start this.
What's your first question solving a quadratic?
Is there a bx term?
Yeah, is there a bx term?
Is there?
And yeah, there is in this one. Next, what should we do?
Primarily disagree. Yeah. No, there isn't.
Set equal to 0 first.
Oh, yeah.
Now do a GCF. Is there one?
No.
No. Okay, then what?
Then you do start. Oh, well, because there isn't a GCF, you can do start.
So we can try star, or if not, we do quadratic.
You can't
So-
go with the start.
So are there factors of 65 added to 8?
Yes.
There are.
13 and 5. Well, it'll be negative 5 if I use positive. I use negative 13 and 5. 13 and negative.
Remember that b, sorry, not b, but the bigger number, the bigger factor matches the sign of b. That's a kind of quick little check.
Oh, I forgot that.
So bigger number has to match the sign of b, so it controls the sign. Anyway.
And then x equals negative 13 and x equals 5.
Yep. And then set equal to 0. This one would probably be the one you need to check if this was geometry. So be careful with that. Yeah, because it's negative. It doesn't always mean that you just kick it out. Sometimes it's fine, but usually the negative one is the issue if there is going to be an issue. How'd that go for you? Awesome. All right. Grab your stuff from yesterday, and let's pick up with this. Oh, you know what? Before we do that, we're going to talk tests. So, proportional, remember, this whole unit is really about proportionality, and that just means we have an equivalent value between two ratios, or more. I mean, it could be 3 or 4 or 5. So to make the ratios, in this case, equivalent, we know the scale factor, which is times 2, top and bottom. Basically what we're looking for is an equivalent decimal, if that's the easiest way to check. And then we did an example, if you need to look at that, that's what you're going to work on here for a little bit. Then we started talking about dilation and scale factor. So I think what we'll do is finish the notes on this stuff and then give you a pretty good chunk of work time today. So, back to this. Remember, one other thing. Did we write what scale factor is? I don't have it on mine. I feel like we did though. It's there. Remember, scale factor, the number we multiply by to dilate a figure. So to make a figure either bigger or smaller. And it's the destination length over the original or origin length. So if we look at this, it says the scale factor from A to B, and then B to A. So the destination changes, and that's important. You need to really focus, if I ask you what the scale factor is, you need to focus on which direction I'm asking it from. So from A to B, tell me about the number that we're going to expect to see. Is it going to be bigger or less than 1?
It's going to be less.
Has to be less because it's decreasing in size. So we say destination length,
0.2.
2 over origin length, 4, which is 0.5, right? Our scale factor, or 1/2, if you want to use that. Now, it should be the same up here as well. So 3 over 6. Either one should give you the same scale factor. And we're going to write today that if they're not, then it's not a similar figure. Okay? How about B to A? Well, now that destination changes.
4 over 2.
4 over 2.
Which is 6.
And same with 6 over 3. Okay? So destination over origin lengths. Okay? How about this one? I don't want you to worry about the length of CD. I want to know the scale factor. What's the scale factor for this one?
5.
It's 5. right? So destination over origin. So scale factor is 30 over 6, which is 5. So now it says, what is CD?
80.
What do we do? Okay, so this is the slow and the kind of basic way of doing these. Yesterday we talked proportions. Here's how I want you to start doing them very soon if you haven't thought of it yet. 30 and 6 correspond, so we're going to say 30 over 6. This is large to small. That's a ratio of side lengths. Match the other side. The other side of our proportion needs to match. So large to small, otherwise our ratio is not set up correctly. So this is CD over 16. Okay? Remember yesterday I told you the solving is typically going to be the easy part. It's setting it up correctly that will be the challenge in these. So that is a correctly set up proportion. There are several other ways we could have done this, like 6 over 30. What would this side have to be if I set this first side up like that? 16 over CD. So that is equivalent to the purple version. This would be small over large, which is totally fine. It's the same. We could also flip-flop the sides as well. So there's typically 4 different ways you can correctly write a proportion. How did we solve? Let's just go back to this one. Cross multiply and set equal. That was our little mantra, right? So 6 times CD, or you could just call it X, equals 30 times 16, or 480. And so divide that by 6, and you get 80. Okay? Cross multiply, set equal, that was our mantra. But this is starting to show you how we're going to use proportions to solve figures now. Okay? Set up a valid or a true proportion and then solve from there. Okay. It says explain why these two figures are similar and find the scale factor. Hopefully you're starting to kind of develop a sense of similarity. We will define it here in just a minute. Are they similar? It says why they are, but let's check. How would we prove that they are similar for sure? What do we use to do that? Yeah, Braden? Okay, sure we could. First, let's check angles. Should these be different?
No, they should not.
Remember the bear and the reindeer pictures? We said the only difference between two similar figures is size. If something looks weird, then it's not similar. So these are marked all congruent, so the angles check out. Now we need to check the ratio of side lengths. So what corresponds to 2?
3.
So if I say left side, let's go left to left. And then over here, pick something else.
I did 7. Over.
You did what?
You do 7.5 under 5. Or 5 over 7.5.
You guys agree with that? Is that okay? We are checking if those are equal. So do, like 2/3 we know, or hopefully you know, is 0.6666. Is this the same? If you don't know, do it on your calculator.
I had them flip-flopped and I just did it and I got 15.
You're saying you flip both of them?
Yeah.
Yeah, okay. So one way you could do is take the decimals. You could also check the cross products. So 15 equals 15. Either one is telling us that those are in proportion, right? The side lengths are. And then we could also include 3 to 4.5 in here. Okay, and then here we get same thing. It's not going to be equivalent to this, but it's still equivalent to the one before it, is what I'm trying to say. How could we screw up the proportion?
You can put 2 over 3 is equal to 5 over 7.5.
No, that was okay.
Well, 3 over 2 is equal to 5.
Okay, so you said it right the first time, but now you're saying, okay. So if we flipped one of these relative to the other and went small to big and then big to small, that's how you would mess this up, okay? Be careful in consistency with your proportions. All right, why are these, and it's obvious, but why are these not similar? The angles. Good job for not saying, well, they don't look similar. Good job. They have different angles, right? They can't be similar if the angles change.
The sides are,
Yeah, the sides are in proportion, aren't they? Okay? All right, let's go define similarity. This is a pretty driving concept in this unit. In fact, the namesake of the unit. Let's make it stand out. So two figures are similar if. Notice we're saying figures. It doesn't specifically apply to triangles. We can have similar rectangles like we saw. We can have similar trapezoids or polygons. So a lot of what we'll prove and work with will be triangles, but it doesn't just apply to that. So maybe underline that and say not just triangles. All right, our two criteria. So in this unit, we get into this word pretty heavily, corresponding. We've seen it before. What does it mean? Let me finish what the next word is, so you at least know what I'm going to say. So all corresponding angles are congruent. But what does corresponding mean? Like if we all stand up and we're standing in anatomical position like this, what does this correspond to on you?
Right. If we were facing each
What hand is this of mine?
other.
What hand is it of yours? Your right. Right? It's got to be the same thing in you as me. Left ear corresponds to your left ear. Okay, so we're not mirroring, we are corresponding, meaning same place in the figure relative to the figure. Make sense? In fact, let's define that, but let's do it in a second because we need that word again for number 2. So all corresponding sides are proportional. So let's kind of flush that out a little bit. Proportional means, or one meaning could be the same scale factor. Could mean equivalent, or does mean, not could, but does also mean equivalent ratio values. Like that's what proportional means. If we set up ratios between all these sides, it should give us the same value. Okay, so what does corresponding mean? Let's not say takes, let's say occupies the same position relative to other features in each figure. So my right hand is your right hand, not your left. Okay? And I want you to kind of relate it to that. Like if we're standing all like this, does it matter if I'm facing the board like you, or facing the back wall, or facing the side wall? Does it matter where we are? Or maybe I'm hanging by my feet upside down. Does it change that my right hand corresponds to your right hand? Right. It does not. Okay? And I'm saying that to say that our figures will be twisted and turned and stuff relative to each other. So how do we figure out what corresponds if it's difficult? Do you remember?
The way it's written out, like A, B.
Yeah, good. Good. Do we need to write a reminder note about that, or are we good on how to use the name? I mean, it's easy. You can just do this. So make up 2 polygons. Like AB goes to EF. Or if you want to do more than one, BC goes to FG, those kind of things. Okay, hopefully that visual is enough to remind you. So 2 figures, let's go back and make sure we're clear. 2 figures are similar if all corresponding angles are congruent and if our side lengths are proportional. Corresponding side lengths are proportional. This is a big deal. This will be the basis for why we prove things are similar. This will be the basis for using similarity. We will, not today obviously, but we will have a chance to go outside and use this to measure things that we can't measure by just sticking a measuring tape. We call that indirect measurement because we can't actually measure it with our measuring tape. It's fun. It's actually very cool. Any questions on what similar means? Okay. Oh, shoot, I forgot the symbol. That's the symbol. So go back to that. And let's put the symbol on there. It's the tilde is the symbol. It's like peeling off the tilde off the congruent symbol and just using the tilde. Okay? So for example, triangle ABC is similar to triangle DEF. Okay? Does geometry kind of make you wonder sometimes where people came up with the symbols? Yeah, math in general does that. All right, back to this. So rectangle ABDC. Why is it ABDC? Just as a reminder, and not ABCD. Yeah.
You have to go in order.
Yeah. Remember, we have to go around the figure, vertex to vertex. Okay. What corresponds to AC in that figure? What was it? RU, right? First and last. Good. This one's kind of fun. I think I'll save this so we get into this a little bit more. Do you guys know, have you ever seen one of those in real life? All right, are the figures similar? If so, state the scale factor. Reduced just means simplify your fraction. So are they similar? What do you check first? Angles, so everything looks good there. So now go to check the side lengths. 10. Thumb up or down if they're similar or not. There is no in between. Okay. All right, a couple of things to point out on this one. How many of you did this at the scale factor? That way. Okay. Which is fine. So compare 2, like we want a vertical or a y and an x dimension. So 9 to 12, or you could do 12 to 9, and vice versa on the other one. Okay. So 9 to 12, what's the decimal or the fraction 12 over 9. If we reduce that, they're both, it's 4 over 3, right? So 1.33. Same thing here. That's okay. You can do that. But we also said side lengths are in proportion. That's times 2. That's times 2. Is that okay? Yeah. Yeah, that's okay as long as you're comparing corresponding ratios. Okay, we wouldn't want to do 9 to 18 here and like 12 to 32 on the bottom one. And I think that's pretty clear, but just make sure you don't do it that way. Okay, probably it would be a good idea to check another, actually not probably, you need to check another ratio as well if you do it this way, just like we did with scale factor. So 9 to 24, you could also do 9 to 9, right? Anyway, are they similar? Yeah, they are. All right, the two quadrilaterals are similar, so we are told this. Find the missing side using, it says using scale factor. I just want you to find the missing side. You can use scale factor if you want. I would rather you use a proportion because that's going to be the more effective way of doing it when the problems get more complicated. Okay? So I'm going to give you a second to do that. Please try setting up a proportion. Okay, so there's multiple ways you could set up a proportion. Tell me if I write 20 to 15, what do you have to write on the other side to match? Go ahead, Brandon. 24 over x. Okay. If I write, let's do 20 to 24, what do you have to write over here? 15 to x. Okay, so this first one went this way, which uses scale factor. The second one went this way and that way. I should put an arrow. Okay? Are either one of those better than the other? No, not at all. Okay, solving, we get 20x. So cross products, we get 20x equals 15 times 24. Thanks. Okay, so either one. You notice, even though this is set up differently, 20x and 15 times 24. Okay? How do you feel about that? These are, again, they're kind of basic solving, but the setup, the concept for setup is pretty similar to what we'll do overall. All right, go ahead and take a break. Let's do 20. So grab your note packet and let's put this in your notes as a enduring example.
Second class, sorry.
Yeah.
No, it is.
Mm-hmm. Okay. All right, so first, you will eventually be able to prove that these two triangles are similar. Well, actually, before I even say that, does everybody see two triangles?
The big one and the one inside the big one.
Yeah, you need to see this as two triangles, not a triangle on top of a trapezoid. And sometimes students mess up because they look at it wrong. Okay? I guess let's talk about a couple things. So see two triangles. And I'm going to recommend drawing them separately.
What do you mean?
I like draw them
instead of having one embedded in the other, draw them out as two triangles.
Did we do something similar to this before?
Yeah, we had overlapping triangles when we did congruence,
Okay.
and I suggested drawing them separately there. They were the same though. Remember those were exactly the same? These are not.
Well, almost. We had to prove that if they were.
Well, sometimes we knew they were, but we had to.
You do proofs.
Was that with proofs? Yeah. So when you draw these out, don't draw them the same size, right? They're not. They need to be drawn smaller and bigger. Okay, so I would start there. If like in the other problems on that page, if, like look at 16, they're already separate. If you look at 19, they're connected, but they're technically separate, right? Remind me to go back to 19 and tell you something about those kind as well, after we're done. Anyway, and then so draw them separately and label known knowns. I'm just going to call it label knowns. So on this upper small triangle, what is the left side? Left side.
3.
It's 3, so we do 8 minus 5. On the big one, it's 5. Okay, on the small right one, it's x plus 2. And then here's where sometimes students get mixed up. How about the right side of the big triangle? Is it 6?
No.
That's what they mess up. They put 6 over there.
It's x plus 2 minus 6 minus x plus.
It's x plus 2 plus 6.
Wait, would it not? It wouldn't be 5.
You just made that same exact mistake on
Yeah,
Yeah,
you did.
yeah.
It would be 8.
Hey, it would be.
Oh, I did. Yeah, thank you. Good job. Okay?
Got me bamboozled.
Yeah, I sure did. Okay, so label. Now it's way easier to see what corresponds and how to set a proportion up, right? Once you do that. In fact, I'm going to put a star on this step. I think that step is probably more important than this next one in terms of correctly doing the problem. Okay, and then step 2, set up a correct proportion.
Something doesn't add up.
What's wrong?
Oh, sorry. It's just like, actually, no, I'm tripping because it doesn't have to be an isosceles, so.
Yeah, it's not. I mean, to me it doesn't look like one, but it doesn't have to be anyway. Okay, so correct proportion. You can do this however. You could do 3 over x plus 2, 8 over x plus 8. You could do 3 over 8, x plus 2 over x plus 8. That's typically how I see this. So little to big, as it says on your paper, would be 3 over 8. Okay? If you're going to worry about struggling, maybe label little to big so that you don't mess up the other side. What's on the right side? What's the little? What goes on top? X plus 2 and then x plus 8. Okay?
Plus. Okay,
And
So let's put a little reminder. I feel like the more times we can write this in, the better. So cross multiply. Remember, cross multiply means diagonally. And then set products equal. Okay? So cross multiply. And we're going to get 3 times x plus 8 equals 8 times x plus 2. Don't forget those parentheses. Okay, and then solve from there like normal. I feel like at this point we kind of know that. Solve as normal from there. So what are we going to get? 3x plus 24 equals 8x plus 16. So we'll get 5x equals 8. Okay. Good. Any questions on that? Look at 19. My gosh, you guys, what the heck's wrong with you?
You're just out of it today.
Yeah. Look at 19. And everybody do this. At me. Everybody do this. Sorry, we're gonna, think about making the two triangles, right? Raise your right arm. You see how it's opposite of me, right?
Okay, so
Raise your left arm. It's opposite of me. So if you look at that problem, AB corresponds to what?
BC.
CB or BC. EB corresponds to DE. So it's always the opposite side, just like we just did. All right. I think what we'll do is those 4 problems on the proportion sheet and then this page. We'll start with that. Okay? And yes, it's homework if you don't finish.
Later ones.
We'll pick up with the other ones tomorrow.
That's a lot.